We're graphing linear equations. But before we get into graphing linear equations and actually putting them on a coordinate plane, it helps to understand what it is we're graphing. So if we have a linear equation with variables x and y, a solution to the linear equation is any point, any pair of x, y coordinates that make the equation true. So what we want to do in example 1 on lesson 4.2 is figure out which of the given points is actually a solution to the equation. The first option they give us is 3, 4. So we want to see if that is a solution. We take and plug in 3 for x and 4 for y. And we're checking to see if that's a true statement. Does 9 minus 4 equal 7? No. So 3, 4 is not a solution. All right, well, let's try another point. Another point that they give us is 5, negative 3. Does that fit the equation? Does 3 times 5 minus negative 3 equal 7? Well, 3 times 5 is 15. Minus negative 3 is the same as plus 3. That does not equal 7. So that's also not a solution to our equation. So that means that those 2 points are not on the line that, that this equation gives us. Let's try the point 1, negative 4. So we plug in 1 for x, negative 4 for y. 3 times 1 is 3. Negative 4 is positive 4. And that does equal 7. So 1, negative 4 would be on the line when we graph it. Now, since every line has an infinite number of points on it, it'd be very difficult to find every one of them piece by piece. But the good news is that we only have to find 2 points to get the equation of a line, or to get the graph of a line. Once we have 2 points, we can connect them with an infinite line that will show all of our points. So the first thing we want to do is we're going to rewrite our equation so that we have y equals, this is something we learned last chapter. We add 2x to both sides and we have 2x minus 3. Now, we can make a table. We'll use 3 points just for good measure, just to make sure that we're doing it right. Because if we only have 2 points and one of them is wrong, then our line's going to be way off. If we have 3 points, then the third one acts as kind of a check to make sure that we're right in line where we should be. So let's use negative 2, 0, and 2. If I plug in negative 2 to my equation, 2 times negative 2 is negative 4 minus 3 gives us negative 7. If I plug in 0, 2 times 0 minus 3 is 0 minus 3, which is negative 3. If I plug in 2, 2 times 2 is 4 minus 3. Oops, made a mistake up here. That should have been 3. 2 times 2 minus 3 is 1. So I've got 3 points here. Negative 2, negative 7. Right here. 0, negative 3. Here. And 2, 1. Right here. So what I can do is I can get out my ruler and make sure that these form a straight line. If they don't form a straight line, then that means that I've done something wrong with one of my points and I need to go back and check that. Alright, how about you try one? We'll start with the equation y plus 3x minus 2. So, y plus 3x equals negative 2, sorry. So why don't you make a table with a few points on it and draw a line, and we'll check and see if we got it right. So if we make a table with a few points, first we want to rewrite our equation as y equals, and we'd subtract that 3x, we got negative 3x minus 2. So we plug in a few points. Doesn't matter which ones you plug in, I'm going to use the same ones I used last time. If I plug in negative 2, I get positive 6 minus 2, which is 4. If I plug in 0, I get 0 minus 2, which is negative 2. If I plug in 2, I get negative 6 minus 2, which is negative 8. So I plot those points. Negative 2, 4, 0, negative 2, 2, negative 8. So, do these all line a straight line? They do. We'll make sure that our arrows go in both directions because our line continues forever in both directions. Little glitch there. There we go. Alright, let's do one more problem. We're going to graph two equations. Y equals 2 and x equals negative 1. Now these look different because, first of all, they're separate equations, and they each only have one variable in them. So let's think about y equals 2. Y equals 2 is a line that's going to include every point on the graph that has a y value of 2. For instance, 0, 2, and 3, 2, and 8, 2, and negative 6, 2. All of those points have a y value of 2. And so when we graph a y equals equation, we get a horizontal line at that value. There we go. With x equals, it's a little different because we have a constant x value. And the x value is always going to be negative 1. So we have negative 1, 0, negative 1, negative 6. That was a little off. Negative 1, positive 3. All of those points are going to be on the line x equals negative 1 because they all have an x value of negative 1. And so when I connect these points, I get a vertical line at x equals negative 1. So notice this x equals is vertical and y equals is horizontal. And so whenever you have just a y, you're going to have a horizontal line. Whenever you have an x, you're going to have just a vertical line. That's the whole lesson for the day. We'll cover the other half of lesson 2 tomorrow. If you have any questions, feel free to ask, or you can go back and watch the video. If you're all set, then get started on your homework.